Yes. Good evening, dear participants. Am I audible?
Yes, sir.
Good evening, sir. Yes, sir, you're audible.
Thank you. Thank you. Thank you so much. Good evening, dear participants. Welcoming you all for the eighth day for the International Research Methodology Workshop on uh, Bridging Paradigms on Mixed Method Approach. Successfully, we have completed 7 days, which is 15 hours, and the remaining 15 hours we are supposed to complete. And today, from today onwards, for the next 6 days, we have a resource person, Professor Dr. Ambati Rao sir, to take care of data analysis through NVO and all the process data interpretations. Without much delay, let me today the meeting will be hosted by CMS College of Commerce and Science, and let me formally invite the HOD to do the protocols. Over to you, ma'am.
Yes, sir. Good evening to all distinguished participants, esteemed colleagues, and honored guests. I am M. Sri Sujata, Head Department of Social Work, CMS College of Science and Commerce. It's my privilege to formally welcome you to the 8th day of the 2 weeks International Research Methodology Workshop on Bridging Paradigms, Global Training on Mixed Methods. Over the past week, we have traveled through diverse methodological landscapes, exploring the depth and rigor that mixed methods research brings to the academic inquiry. Today, as we continue this enriching journey, we reaffirm our collective commitment to advancing scholarship that is both methodologically sound and socially relevant. It's with great pleasure that the department extends a warm and respectful welcome to our esteemed resource person for the day, Dr. Ambati Nageshwara Rao, Assistant Professor of Social Work, former Dean, Research and Publication Division, Gujarat National Law University, Gandhinagar. Dr. Rao distinguished contributions to the fields of social work, research methodology, and interdisciplinary qualitative and quantitative paradigms stands at the heart of today's theme, and we are privileged to have him guide us as we delve further into the art and science of mixed methods research. Welcome you, sir.
Thank you so much.
To all participants joining from various parts of the world, your continued enthusiasm and active engagement have enriched every session of this program. As we enter the second week of this transformative workshop, I encourage you to carry forward the same intellectual curiosity and collaborative spirit that have defined our learning community so far. Once again, I extend a warm welcome to each one of you. May today's session be insightful, inspiring, and deeply productive. Thank you, Arundhati. Thank you.
Thank you, Professor. Thank you so much for the wonderful invitation and introduction. Thanks a lot. Thank you.
Thank you.
I'm sharing my screen. Just let me, ma'am. Yeah. I hope my screen is visible, madam.
Yes, sir. Visible, sir. Visible.
Yes. Thank you. Yes. Okay. On behalf of myself, first of all, I would like to thank all the organizing committee members, especially starting with Indian Sociological Society, RC25, and especially Standard College Manipur, Imphal College Manipur, and Kaching Kongo College Manipur, and all the organizing collaborators, especially IIDM, Royal College of Law, and CMC College of Science and Commerce, Tamil Nadu, Sri Padmavati Mahila Vidya Viswavidyalaya, and KPE Society, Ambedkar College. Thank you for all the organizing committee members and organizing secretary members, and especially all the research scholars, faculty members, and academicians. Thanks for the wonderful opportunity. Yeah. Coming to the, as sir already mentioned about next 6 days. For the next 6 days, we are going to talk about qualitative and quantitative data analysis techniques. As a part of day one, that is, I can say that day one, that is for my side, 27, 28, 29, I'll be talking about SPSS, how one can analyze the data with the help of the quantitative software, that is SPSS. So as a part of the next 3 days, today till 29th, we'll talk about quantitative data analysis using SPSS. Coming to the next 2 days, 30th November and 1st December, I'll be talking about how to analyze the data by using qualitative data analysis, especially NVIVO. As a part of the December 2nd, I'll be talking about how to integrate both quantitative and qualitative with the help of mixed methods. I'll also talk about triangulation, convergence, conformity, theoretical part as well as practical. Hands-on practice, we are going to have it. So coming to the first one, as a part of today's session, let me open the other PPT we have. So I would like to acknowledge various scholars. I have already shared a couple of ebooks, but I'll be keep sharing a couple of e-materials, sample data sets, sample research papers time to time. Please ensure that you might be checking time to time your Google Drive link. Okay. So I would like to acknowledge the contribution of this particular scholars for their contribution. As a part of today's session, I'm going to give the overview of basic concepts of quantitative data analysis. So instead of simply jumping directly how to use SPSS, how to start SPSS, we are going to have at least of next 40-45 minutes about what are the basic concepts one should know if you want to start with your statistical analysis part. So having understanding about basic terminology that may help us to directly start working with the data. Because next 3 days, today and tomorrow, day after tomorrow, we are going to deal with a lot of data sets, starting with single frequency, cross tabulations, chi-square test, comparison-based test, relationship-based test, regression analysis. And if time permits, I'll also talk about structural equation modeling, if time permits, okay? So next 3 days, we are going to talk about so many statistical techniques. So before that, I just want to have basic understanding of how to conduct the hypothesis. So what is the procedure for conducting hypothesis test? Once we complete for the overview of basic concepts of quantitative data analysis, I believe that many of you might have installed the SPSS software. So we are going to look at the interface of the SPSS, how to enter the data manually, what are the basic features of SPSS, how to enter the, once we conduct, how to enter the data manually, how to import the data. As many of us are these days conducting online surveys, Google Forms, how one can import the data, how you can start cleaning your data. And we'll also talk about a couple of characteristics like transformation, computation, missing value treatment, certain data transformation techniques also we are going to discuss as a part of it. Okay. Now, as I mentioned, overview of quantitative methods. Imagine that all of you have conducted a study. You have some research tool in your mind, or you already have research tool with you. Okay. Now look at this particular tool. So if you look at this particular research tool, you can able to see that questionnaire on inclusive education for students with disabilities in higher education institutions in India. So as a part of my research, I have collected data by using research tool. Now, as you can see, this particular tool, it is consists of a lot of closed-ended questions. As a part of quantitative research, I'm have structured a questionnaire. I have it. I'm just going to use this particular tool for collecting data. Once we collect the data, I'll start analyzing the data, right? Now, the moment I start analyzing data, what kind of statistics I have to use it? No. Now, are you going to realize, are you going to think about statistics once you collect the data or after collecting the data? I mean, before collecting or after collecting it? If you look at your research proposal, along with the research questions, research objectives, as a part of your research methodology, you might be talking about what kind of data analysis that you're going to carry out. If you look at some of your research methodology part, the way you are framing your research objectives or the way you are framing your research hypothesis, people can understand whether you are going to conduct descriptive statistics or inferential statistics. Or maybe, let's take for example, people can understand whether this particular study is going to be like regression analysis. What are the possible tests can be conducted? By looking at the title, by looking at your research hypothesis, people can able to sense it. Your examiners, your supervisors can able to tell you, looking at the way you're framing your research hypothesis, they can tell you, okay, this kind of data analysis is possible for this particular hypothesis, right? Now, what I means to say that we should not think about what kind of data analysis we'll do once we collect the data. We have to keep as a part of research design, as a part of research plan, while framing your research objectives as a part of your research purpose, you will have some clarity whether it is going to be comparative based, is it going to be relationship based, is it going to be cause and effect relationship, right? So you have something, some kind of tentative plan in your mind while framing your research questions, research objectives, or research hypothesis. Now, once we collect the data, there are two options: descriptive statistics, inferential statistics. If you are going to use quantitative research as a part of your research objective, there are two options. One is descriptive statistics, second one is inferential statistics. When I say descriptive statistics, the main objective is to describe the phenomena that you are observing, that you are collecting data. Like you might be using single frequency table, cross tabulations, like percentages, frequencies, charts. Further, you can also use central tendency, measures of central tendency like mean, median, mode. You might be using descriptive statistics where it may not require for you to use hypothesis. It's not required to go for testing of hypothesis. Whereas when it comes to the inferential statistics, the main objective is to infer your findings with the rest of the population. So you're coming with some kind of hypothesis and you want to test that particular hypothesis. And based on your study, what are the conclusions, what are the inferences that you're going to come? You want to generalize your findings with the rest of the population. So there are two types of statistics: descriptive statistics and inferential statistics. When it comes to inferential statistics, we're going to frame hypothesis, we are going to test our hypothesis. Now, one thing is very clear: when it comes to descriptive, we are going to use percentages, frequencies, cross tabulations. We are going to use measures of central tendency, measures of dispersion, right? But when it comes to the inferential statistics, what kind of statistics we can use it? We are going to have comparison-based test like t-test, ANOVA, chi-square test. We have association means chi-square test. We have relationship like Spearman correlation test, Pearson correlation test. Then we also have regression family, where we'll talk about simple linear regression, multiple linear regression. So there are so many statistical tests we are going to conduct based on the type of the data that we have it, the amount of data that we have collected it. Now, as you can see on this particular slide, there are so many statistical tests that are available as a part of inferential statistics. But how to choose? I'll come to this particular slides again sometime back. Okay. Now, how to choose which statistical test that you're going to use it? So we need to frame we need to follow certain procedure if you want to conduct inferential statistics. First one is we have to frame your hypothesis. First and foremost thing is we have to frame your hypothesis. We have to select level of significance like p-value, and we have to identify the test statistic value, formulate the decision rule, and we are going to arrive at the decision. So I'm going to explain all these steps while explaining some of the important concepts. While framing, while choosing, while deciding which statistical test that you have to use it, we also need to know within the inferential statistics, we have two types of statistics: parametric, non-parametric. In my first slide, I mentioned that we have descriptive statistics, inferential statistics. We have discussed what all things will come under descriptive. When it comes to the inferential statistics, we have t-test, comparison-based test, relationship, correlation, and all. But that particular statistics can be again further categorized on the basis of parametric, non-parametric. Parametric statistics are considered as more rigorous, more robust as compared with the non-parametric statistics. For example, if I'm talking about t-test, comparison-based test, I can conduct either as a part of parametric or as a part of non-parametric. Only thing is, under parametric, we have different kind of comparison-based test. Under non-parametric, we have different kind of alternative comparison-based test. Second point, parametric statistics considered as more rigorous, more robust as compared with the non-parametric. Now the question is, when to go for parametric, when to not to go for non-parametric statistics. So it depends on the type of the test that you're conducting. Every statistical test have certain assumptions. Like if you want to go for any job, you're required to fulfill certain eligibility criteria. Similarly, if you want to conduct any statistical test, you should be able to fulfill certain criteria. You cannot decide I can conduct any kind of statistical test. The kind of data that you have it, the kind of data collection that you have collected, that is going to decide whether you can able to use particular statistical test or not, right? So now when I talk about parametric assumptions of all the statistical tests, as we are going to deal with many of the statistics, right now I'll talk about 4 basic assumptions which are very important for any statistical test. Point number 1, every statistical test have different assumptions, different kind of assumptions. But most of the statistical tests have certain basic assumptions like independence of observations. Means if I'm collecting data from male and female, if I'm collecting data from the male and female, I should not manipulate my data. I should have respect to data for the male, respect to data for the female. So I'm collecting data from each individual. I should not treat male data as also as a female data. Independence of observation. Second one, normality distribution. Whatever the data that you are collecting it should be distributed normally. When I say normality means, if you look at this particular slide, it shows that there is a bell curve. It is nothing but the data that you have collected as a part of your research work. If you prepare histogram, this is the histogram. If you prepare the histogram, it shows you how your data, what kind of data that you have collected. Let me put it more simple layman point of view. When I say it shows how you have collected data means, if I want to collect the data, if I want to conduct any statistical test, my data should be normally distributed. If I'm getting symmetrical curve, like if I'm getting proper bell-shaped curve, you can call it as our data is distributed normally. Let's take, for example, if my data is like this. You can able to see some slides where you can able to see that left tile, right tile, where you won't see proper bell-shaped curve. It is not this is not symmetrical. This is not symmetrical data. Okay, you can see this data is not properly collected. It means if I'm talking about my students' placement record at my campus, what I'm going to do is, if I'm talking about my placement record in my institute, if I'm talking about based on 5 students, I'm saying that on average, my university placement record is around 50 lakhs rupees. Means I collected data from 5 students. Based on the 5 students, I'm saying that on average, my university students are getting annual packages 50 lakhs rupees for a year, per annum. But if you look at the figures of this particular 5 people, first person is getting 10 lakhs, 10% is getting around 12 lakhs, third person is getting around 10 lakhs, fourth person is around 8 lakhs. And imagine that the 5th candidate is getting around 2 crores. Okay. Now, if I calculate it, this is 2 crores. Okay. If you calculate it, 10 plus 12, 22, 32, 40, 2 crores 40 lakhs divided by 5 people. So whatever I'm going to get the value here, based on that, I'm going to say that on average, my students are getting 45 to 50 lakhs annum. But is this particular figure is correct? No, because this particular figure, this 2 crores is deviant from the mean value. Let's take, for example, here, let me go to the next slide. For example, I'm taking the IQ score of, I'm calculating the IQ score. Okay. And 100, the figure that you're 100 that you're seeing right now, this is nothing but mean is equal to median is equal to mode. On average, people IQ score is 100. This is the mid value, midpoint, average score. But there are people less than 100, there are people greater than 100. Now, the person who is, it is 1 standard deviation, minus 1 standard deviation, plus 1 standard deviation. Now, I can see that 85 to 100, 15, 100 to 115, 15. This 68% of the data, this 68% of the data is falling between minus 1 standard deviation, plus 1 standard deviation. Now, how, from where I got the 68? If you calculate the data set, 1 minute. For example, minus 1 standard deviation plus 1. 34 plus 34, 68. Means if I collected data from 100 people, 68% of data comes here. Okay. And remaining, if you look at minus 2 plus 2 standard deviation, it comes around 95% standard deviation here. 95% standard deviation, we have it. Now, remaining 5%, 2.5% left side, 2.5% right side. Based on the left tile, one tile, two tile test, you can able to decide whether 5% or 2.5 or 2.5. Let me give the overview 1 minute. One of the important assumption of your data analysis is that if your data, whatever data that you collected, if data is having normality distribution, means if you're getting bell-shaped curve, it means your data distributed normally. It means average score, the mid value should be here, and it shows that the mid value, the mean is equal to median is equal to mode. This particular point, based on the histogram that you're going to get it, that is going to tell you whether your data is having normality distribution or not. If you're having normality distribution, that is you are able to clear one assumption that you can go for parametric statistical test. Second point, random sampling technique. Whether you have collected data by using probability sampling, non-probability sampling techniques. If you collected data by using probability sampling techniques, especially random sampling techniques, you can go for using parametric statistics. Now, somebody can ask me, sir, my data is not distributed normally, but I have huge data. My sample size is very big. What can do that? If a sample size is big, whether your data distributed normally or not, you can go ahead with conducting parametric statistical test. I'm repeating again. Earlier, I mentioned that if your data is not distributed normally, if you're not getting bell-shaped curve, in that case, you cannot go ahead with conducting parametric statistical test. But if you say that, sir, my sample size is big, in that case, if your sample size is big enough, good enough, and then in that case, you can overlook at the normality distribution, you can go ahead conducting parametric statistical test. Further, we also have various softwares. Like for example, partial least square structural equation modeling. We have software called SmartPLS. It is advanced level statistics. By using this particular software, even if your data is not distributed normality, one can go ahead with conducting structural equation modeling statistical test. On the other hand, we also have one more statistical test, CBSIM, covariance based structural equation modeling. In that case, if you want to use covariance based structural equation modeling, your normality distribution is mandatory, irrespective of your sample size is big or not. Okay. So what I means to say that every statistical test have certain assumptions, certain criteria, one has to fulfill it. Okay. Now, so we discussed about independence of observation. Normality test, for conducting normality test, we are not only having histogram like bell-shaped curve, Tomorrow class, I'm also going to discuss about various other statistical tests which you can use as an alternative. Like we have Sperry-Wilkie test, we have box plot, we have Skinner's and Curtis's, we have stem leaf. So there are other statistical tests which you can use as an alternative to normality test. But conducting normality test is a common, or it is one of the important assumption of every statistical test. Okay. Next one, levels of measurement. Levels of measurement is nothing but the type of data that you have it. Let's take, for example, if you look at your entire research tool, you may have 10 questions or you may have 50 questions. If it is a quantitative research tool, you are going to classify your data under 4 categories of data. I'm repeating again, whether it is whether in your research tool, whether you have any 10 research questions or 50 research questions, mostly you are going to classify your data under 4 categories of data, 4 levels of measurement. You can call it as a levels of measurement. You can call it as a types of data. They're nothing but nominal data, ordinal data, interval data, ratio data. Scholars used to classify in different manners. Depends on the textbook, depends on the scholar's understanding or explanation. They differentiate. But overall, we have 4 types of data we have it. Further, there are some scholars as a part of the simplification. Further, we have categorized 4 levels of measurement under 2 categories, like qualitative data, quantitative data. I'm saying as a part of quantitative data itself, we have qualitative and quantitative. Let's say, for example, if you're looking at the nominal data, if you are going to classify your data on the basis of specific classifications, specific labels, specific categories, like gender, like name of the university that you belongs to, like public university, private university, deemed university, central university, state university, urban area, rural area, semi-urban, like all of you are using your smartphone, right? So I can see that LG company, Tata, Moto, whatever. There we have different. So if you are classifying your data on the specific labels, specific classifications, we can call it as a nominal data. As it is overview, I'm not going detail, but if there are any questions, maybe after 45 minutes, I'm going to take the sessions, question and answers. Okay. Second one is how ordinal data. If you're going to put your data in the form of order, in the form of ranking, like first class, second class, third class, or grade wise, A grade, B grade, C grade, or if you're going to have like a Likert scale, strongly disagree to strongly agree. Now, when I say Likert scale, some of the professors may not be agree. There is a debate about whether one should consider Likert scale as ordinal data or interval data. So that debate is never ending from last so many decades. So we don't want to discuss about it. You have a choice whether you can consider Likert scale as ordinal data. You can also consider Likert scale as interval data as well. So it depends on your supervisor, your doctoral committee members. You can choose or you can name it. Okay. So ordinal data, when you talk about the ranking, when you talk about the order, let's take for example, I collected all of your annual income. Okay. So I'm going to categorize your annual income like low income, middle income, high income. If I'm taking all of your height, tall, small, medium, height, means if I'm putting some order, some position ranking, or it comes under ordinal data other than Likert scale. Next one, we have quantitative data, where we say that continuous data, discrete data. When I say continuous data, numbers that can be broken down, such as height, weight. Let's take, for example, if somebody asks your height, you're going to say that 66.5 inches, or 5.6 feet, or 6.21 feet, or 6.0, right? But if you ask somebody, how many children do you have it? They say that I have 2 children. I have 1 child. So that comes under discrete data. So if you have some continuous, if you're getting some kind of decimals, if you're going to have some kind of decimals, in that case, you can able to see that it comes under continuous data. If you don't have discrete, if you're going to have specific, if you don't have any decimals, it comes under continuous. If you have specific number like 1, 2, 3, 5, what is your age? My age is 39 years or 40 years or 41 years. If you're going to say this particular way, that comes under discrete data. Now, the point here is that in order to choose the type of statistical tests that you want to apply, you also need to understand as a part of your research tool, as a part of your data collection, what kind of data that you have collected it. Like, do you have ordinal data, nominal data, interval data, ratio data? So having type of data that is going to influence the kind of statistical test, you can use it. Simple example. If I want to use chi-square test, I should have two qualitative data. Like if I want to conduct chi-square test, within the chi-square test, we have two types. One chi-square test is required two qualitative data. It can be nominal, it can be ordinal. If I am going to have nominal ordinal data, I cannot conduct any t-test. I cannot conduct correlation test, right? I cannot conduct completely ANOVA test if I have only two categorical data, two qualitative data. So in coming classes, in coming slides, I'm going to discuss what are the statistical assumptions are required or what are the eligibility criteria are required to choose particular statistical test as a part of your research work. Okay. So whatever I discussed right now, these are the four basic assumptions which are common for every statistical test when it comes to the parametric statistical test. Whereas when it comes to the non-parametrical statistics, normality test is not required. Random sampling is not required. When it comes to the levels of measurement, if you have qualitative data, you can go for it. So let me go with this next. So as a part of statistical test, first part is that how to frame the hypothesis. What is hypothesis? I believe from last 1 week, somehow one of the other faculty might have discussed. Hypothesis is nothing but tentative assumptions. You're coming with some kind of assumption in your mind based on the existing literature that you have gone through that, or based on the theories that you have gone through that. We generate hypotheses from various sources, like going through the literature, attending conferences, talking with the people, going through your personal experiences. Of course, you may have personal experiences, but you also need to see some supporting literature which can support your argument. Or maybe you might have gone through a lot of theories, or you might be looking at some interdisciplinary concept. You're trying to connect certain concepts from existing literature, right? So today, whatever the development is happening, everything is because of research. People are guessing, people are assuming something we can do like this way, we can attempt like this way. People are conducting experiments. So the first point is that framing hypothesis, having some kind of assumption in your mind that makes us to work on that particular concepts to see whether is there any association, is there any relationship, is there any cause and effect relationship. So basically, as a researcher, you are going to test your hypothesis as a part of your quantitative research. Dear participants, dear scholars,
Yes, sir. Now you can speak, sir. Sir, we have closed the meeting.
okay,
Now you
okay,
can speak. Sir.
okay. Thank you. So when to frame the hypothesis, especially when you are at the early stage of your research process, when you completed your literature review, when you are aimed to look at the relationship between couple of variables, are you trying to test the theories, right? So in that case, one can frame the hypothesis. Now, within the hypothesis, I just want to talk about generating the hypothesis, testing the hypothesis. When I talk about generating the hypothesis, are testing the hypothesis. It all depends on the type of research that you carry out. Today, as a part of international workshop on mixed research methodology, you are here. It means you are having basic understanding or sufficient amount of knowledge about what all methods are coming under qualitative research, what all coming under quantitative research, and how you are going to combine both quantitative and qualitative research. Means every research methodology have different philosophy, different approaches we have it. Like we have Dr. Sundar, he came with a concept called research onion. This particular concept is going to help us what are the steps one has to carry. If I'm going to choose positivist approach as a part of my research work, where I'm going to use quantitative research methods. If I'm going to use interpretist or constructivist, I'm going to use qualitative research. If I feel either quantitative or qualitative is not able to justify my research work, I'm going to use the combination of both quantitative and qualitative research work. Okay. So it depends on the philosophy that you're going to follow. You're going to have inductive, deduction, abduction methods. That's how we are going to choose the data collection methods. Now, the point that I want to highlight here is testing of hypothesis, generating the hypothesis. As a quantitative researcher, it is mandatory that you are going to test your hypothesis, you are going to frame your hypothesis, and you will see what are the results that are going to be there. But whereas when it comes to the qualitative research, as an outcome of your research, you are going to generate hypothesis. You are going to develop the theories as an outcome of your research work. I have seen the schedule. There are sessions on what is qualitative research, what is quantitative research, right? Now, the point that I want to highlight is that how, as a researcher, you are going to generate hypothesis. How you are, as a researcher, how you are going to test the hypothesis. That is a point I want to discuss. There is a study conducted by Catherine. Okay, it's all about how boys and young men learn about menstruation. How boys and young men learn about menstruation. As you all know that generally we don't talk about menstruation at family level, at school level. If it is rural area, it is very horrible. Most of the teachers, they used to avoid concepts about reproductive rights, primary parts. Being a boy, being a man, if you're not able to get the knowledge, if you're not able to know something about women, that is 50% of the population, how you're going to cooperate with them, how you're going to support them. Forget about your cooperation, your support. How we are able to understand their problems. Most of the time we criticize right to education is a failure. But are we able to understand why there is high dropout rate among adolescents girls in the rural areas? What kind of sanitation support services they have it? What kind of toilet support services they have it? Now, the point that I want to highlight is that as a researcher, I want to conduct research on menstruation. Unfortunately, I couldn't find any research studies. Now, the best part is that I'm going to start interacting the people. Based on my interaction by conducting in-depth interviews, observations, or focus group discussion, I'll learn something about what is happening with this particular phenomena. This is one of the best example I'm saying about when to use mixed methods. I want to use mixed method research, okay, but situation demanded me to go for, I decided to go for quantitative study. I decided to go for quantitative study to understand the attitudes, perceptions of boys and men about menstruation. But I couldn't prepare my research tool. I don't have much sufficient literature. I don't have sufficient knowledge to prepare my research tool itself. As a human being, we have limited talent, maybe. Okay, it depends on the area, depends on the exposure. Now, as there is a limitation of research, as I'm not able to go ahead further, what I did, I thought of interacting with the people to understand when they started learning about menstruation for the first time. So based on conducting qualitative study, based on the findings of the qualitative study, I'm going to prepare my quantitative research tool. That is from the point of mixed methodology. But from the point of generating the hypothesis, As there are no studies, in qualitative studies, we have grounded theory, phenomenology, ethnography, case study. There are so many methods. Especially the grounded theory is going to help us to understand what is the process being a boy, being a man, when they started learning about menstruation. If you want to understand the process of certain phenomena, particular event, particular incident, I'm going to use grounded theory as an approach. So I'm going to develop the theory from the raw data that I'm going to collect from the field. I'm going to propose certain hypotheses or propose certain theories as an outcome of qualitative research work. Whereas when it comes to the quantitative study, let me discuss one interesting study. It was published recently in the June 2025. This particular article is available. That is on women's attitude towards physical intimate partner violence in India, trends, patterns, and determinants. I just want to understand what are the attitudes towards women's attitude towards physical intimate partner violence. So the scholar framed hypothesis based on two theories. One is social learning theory. Second one is resource dependency theory. Social learning theory says that being a woman, being a girl, being a daughter, if you have seen how my father tortured my mother, or what kind of violence, what kind of uh, fighting is happening between my father and my mother, if I experienced it, I experienced that my mother is simply accepting whatever my father is doing on it. She felt that this is what happens in the family. Family means we are going to have quarrels. We have to adjust whatever my husband does it. Just because her mother, she has seen her mother followed the same pattern, right? Just because in my families, my neighborhood families, my mother was not talking anything because if as a woman, as a mother, if I raise my voice, what is going to happen to my life? Forget about my life. What is going to happen to my children's? So thinking about children's point of view, she's not, just tolerating it. Her tolerance level is very high, irrespective of severity of the torture, okay, violence. Whereas resource dependencies theory says that the people those are independent, the people those are able to uh, get their own needs, they can able to fulfill their needs. This their tolerance level is very low, because if you talking about right, which is correct, there always argument starts at the family level, right? Being a woman, if you are independent, that is the best part of your family. It's not just only for you. You are going to take care of the entire family. You are going to participate in all the family decisions. You don't need to wait for taking permission from your husband, even to buy small things for your son, for your daughters, for your children's, right? So resource dependency theory says that the women who are independent, their tolerance level is less. Why I'm saying the tolerance level is less? They're able to tell what is correct. They're able to raise their voice. This is wrong, this is correct. They're able to tell to their husbands. So as a result, you can see that a lot of adjustment problems will come. So I request you all, please go through this particular study. Findings are very interesting. The point that I want you to take from this slide is that if it is a quantitative study, you are coming with either existing literature or existing theories, and we are going to test that particular theories in our research, in our field. So having theory is going to help you to frame what kind of hypothesis that you're going to frame, what kind of hypothesis that you're going to test it. It is going to give you the proper direction. It is also going to give you a proper scope. What are the variables are going to be included as a part of your research work. If you don't have proper direction, if you don't know what is the scope of your research, you start collecting data from everywhere, but you can't justify not even single object or single objective or single hypothesis. Okay. So the point is that what kind of theories, there are so many theories, irrespective of the background. For example, if you're coming from sociology, you know, all sociological all theories, more than any other scholar. I don't know, I'm sorry to say this. Talk about classical sociological theories, modern sociological theories. Even if you're coming from social background, psychology background, management background, or even law background. Every discipline have certain perspectives, certain theories, certain approaches which are ready to guide you. These theories, these approaches are nothing but how you're looking at your problem, how you're trying to address your problem. As a researcher, this particular theory is going to guide me how I'm trying to understand this particular problem, how I'm trying to solve this problem, how I'm trying to solve this particular problem, right? So, in order to frame your hypothesis, in order to test your hypothesis, having theories in your mind is one of the most important aspect. Only thing is whether you are going to generate a hypothesis or you are going to test the hypothesis. If it is a qualitative research, you are going to generate a hypothesis, means you are going to develop the theory. If you are quantitative researchers, you are going to test the hypothesis. Now it is mixed method, what you're going to do it. As you are attending from last 1 week, it depends on the dominance, whether whether you hang more qualitative approach or more quantitative approach. So I think that is already you might have discussed. Maybe we'll discuss in coming classes. That is at least 2nd December, I'm going to discuss more on about it. Okay. So till 2nd December, I just want you to wait with reference to integration, convergence, or triangulation point of view. Okay. So we have framed first step is how to frame the hypothesis. We have done that particular part. Now, where is this? Yeah. Okay, coming to this particular slide again. As a part of the step number 1, we have to frame the hypothesis. We have null hypothesis and alternative hypothesis. Null hypothesis is nothing but you always say that there is no significant difference, there is no significant relationship, there is no significant association. Okay. So you're going either you can say that there is no significant relationship or significant association, or both are equal. Let me show you the slide. Look at this particular hypothesis. There is no significant difference in sentencing outcomes between male and female defendants in the Indian criminal courts. As a researcher, I'm framing a hypothesis saying that there is no significant difference in sentencing outcomes between male and female. Whereas when it comes to the alternative hypothesis, there is a significant difference in sentencing outcomes. Means just opposite you are saying in the form of alternative hypothesis. Now, if you look at some of the textbooks, you might have seen, some of you might have read or might be teaching as well. Directional hypothesis, non-directional hypothesis. Directional hypothesis, non-directional hypothesis. When you're going to frame directional hypothesis, non-directional hypothesis, your null hypothesis will be the same. Whereas when it comes to the alternative hypothesis, you are going to give some direction. Let's take, for example, I'm going to say that male students or male employees are performing greater than female employees. I'm going to say that when I'm doing a directional hypothesis, non-directional hypothesis, male employees are performing better than non-employees. Look at here. For example, when I say directional hypothesis, it is a one-tail test. It can be left tail, it can be right tail. If I'm not, I hope I'm not confusing giving more hypothesis types, but having knowledge about different types of hypothesis is going to help you how we are going to frame your hypothesis. Okay. So we know null hypothesis, we know alternative hypothesis. We also have concept called directional, non-directional. Direction means it can be left tail, right tail. It means basically one tail. How to understand it? For example, my null hypothesis is that children born prematurely have mean IQ. Children born prematurely have mean IQs that are not different from those of the general population. So here I'm comparing two groups, those who born premature babies with the general birth babies. Okay. Now, when it comes to the alternative hypothesis, the children born prematurely have lower mean IQ than the general population. Means here I'm saying that it can be lower, it can be higher, it can be increased, it can be decreased, it can be greater than, it can be smaller than. Basically, here I'm giving some direction. That's why it is called directional hypothesis. Directional hypothesis is always one tail test. It can be left, it can be right. It can be increased, it can be decreased. It can be lower, it can be higher. There are certain basic terms which we use it. I just brought the slide. Yeah, 1 minute. These are the basic common phrases that we use it when it comes to framing your one-tail test. Increased, decreased, greater than, less than, higher than, above, below. These are all nothing but directional hypothesis. Now, how directional hypothesis is different from non-directional hypothesis? How directional hypothesis is different from non-directional hypothesis? Let me show you that. Look at here. The null hypothesis will be the same. The null hypothesis will be the same, whether directional hypothesis or non-directional hypothesis. Null hypothesis, the way we are going to frame it, will be the same. But when it comes to the alternative hypothesis, here I am saying that children born prematurely have IQ scores that are different from children born prematurely have IQ scores that are different from children born from general population who had full gestation. Here I'm not saying lower or higher. It can be lower, it can be higher. It can be decreased, it can be increased. As a researcher, I'm not giving any direction. Here I'm not giving any direction. It can be lower level, it can be left, or it can be right. So that's why it's called non-directional test, or it can be called as a two-tailed test. So maybe in coming classes, I'll talk about it, what exactly, when to use this one. The next point is that other than directional, non-directional hypothesis, critical value, critical region. Okay, I have framed my hypothesis. I'm going to conduct the test. I'm going to get result like this. This is the output I'm going to get it. But in this particular output, there are so many figures. There are so many statistical tests we have it, right? Like something like p-value, we have it. Degree of freedom, we have it. T-static, we have it. Confidence interval, we have it. So I just want to understand what is this particular p-value, what is this particular figures all about, one by one. Okay. Let me talk about the t-statistic test. Okay, t-statistics test. We have two concepts: critical value, critical region. Critical region is nothing but, if you look at this particular data, I brought 3 histograms. Once I start looking at my histogram, that bell-shaped curve, if you look at the completely left side figure, that is first one. Here, critical region, left side, right side. That is 2.5 left side, 2.5 right side, I have it. This is called two-tailed test. This is called non-directional test. I'm repeating again. The left side we have minus 2.5, right side we have plus 2.5. We have 2.5. This is called nothing but region of rejection. If my values falls here, I'm going to decide whether I'm going to I'm going to reject my null hypothesis, whether I'm going to fail to reject the null hypothesis. Okay. Now, what is this particular region? This is the area under the curve where if test statistic, that is nothing but this particular value. Please listen to this particular figure. Static test This is the area under the curve. If the test static, that is z value, that is t static, nothing but z value, false, you would reject the null hypothesis. The shaded areas in the diagram represent this region. If the test static lies within these areas, we have sufficient evidence to reject the null hypothesis. If my p-value is going to be less than 0.05, if my p-value is going to be less than 0.05, I'm going to reject my null hypothesis. Because if p-value is less than 0.05, I'm going to say that there is a significant difference between what are the variables that you're looking at. For example, I'm looking at gender and academic performance. I'm saying that female employees are performing better than male employees. As a part of my null hypothesis, I'm framing that there is no significant difference between male and female employees on the basis of academic performance. But my p-value I got less than 0.05. It means I'm going to reject my null hypothesis, saying that there are significant differences between male and female because female employees are performing better than male employees as a example, as a part of example. Okay. Of course, in reality also we can see, right? Now, the point is that the critical region, you are going to decide whether it is going to be 5%, like a 95% confidence interval, sorry, 95%, 99%, 90%. The p-value, if you belongs to social science, you'll go with 95%, and there's a 5% margin of error. As a scholar, if you belongs to health science, pharmaceutical company, if you're working on drugs, medicines, or if you feel I want to go with more reliable and valuable validity findings, you'll always go with level of significant 1%. There are very rarely they used to go with 10%. Somebody can ask me why not 100%. Because as a human being, as a social scientist, if you're going to interact with human beings as a part of social science research, there is always scope for error can take place. Knowingly or unknowingly, there is always scope for error. So 5% risk, we'll go for it, right? Let me explain this concept. The level of significance is the probability of rejecting the null hypothesis when it is actually true. It determines how confident you must be in your findings before rejecting the null hypothesis. The common values are 0.05, that is if you are going with 5%, 0.01, that is if you're going with 99%, 0.10 if you're going with 90%, right? Lower alpha value, lower p-value requires stronger evidence to reject the null hypothesis. Okay. In a study where a researcher is testing whether a new drug works, if the p-value is 0.05, the allowing 5% chance of rejecting the null hypothesis. So the end point that I want to tell you is that if my p-value is less than 0.05, it means that there is a significant difference between the variables that you're looking for it. Let me give one more example here. Here, right now, you are looking at these particular values. Here, looking at these particular values, p-value is less than 0.05. What I'm saying that as a part of my data, I'm framing my null hypothesis saying that there is no difference between population mean and sample mean. Population mean and sample mean. I collected data from all the sociology researchers, faculty members. Please don't take it other way. I'm also a sociologist. I also have social work as well as sociology background. I collected data from all sociologists, irrespective of research scholars, faculty members, everyone. And I have published a report in the year 2024. I have measured their height. On average height of sociology faculty members or research scholars is 66.5 inches as per the report submitted by Indian Sociological Society. Indian Sociological Society conducted study hypothetically, and 66.5 inches. There is a population throughout all over India. As I'm working in Gujarat, I can't collect the data from the entire India. I collected data from all sociologists in Gujarat. Okay. And I collected data from 50 people. I collected data from 50 people. Now I'm going to compare. This is the sample. 50 is nothing but sample. Okay. This is the population. Now, as for my sample, mean height is 68%. I collected data from 50 people. Average mean height of sociologists in Gujarat is 68. So here 66.5 minus 68, how much I'm getting? 1.58 difference. So as a part of your report, what a part of your statistics, there is concept called mean difference. If you're conducting t-test, this is nothing but this is the difference between sample mean and population mean. Okay. Whereas this particular figure is talking about p-value. If your p-value is less than 0.05, it means there is a significant difference between population mean and sample mean. It's not occurred by error or chance. There is a statistically significant difference between population mean. What is the population mean? All over India, as study conducted by Indian Sociological Society. And there is a difference with sample mean. What is the sample mean? Gujarat Sociological Society, Sociological faculty members. So there is a difference of 1.5 inches here. 1.5 inches we have it. Okay. So p-value decides whether there is a significant difference or not. Now the end point that I want to take is that as a scholar I can take 99%, 90%, 95%. Now when it comes to social science, management, humanities, we always go with 95% significant value. If I'm going with 95% means my p-value should be 0.05. My p-value should be 0.05. But if I'm going with 90% means my p-value will be 0.10. If I'm going with 99% means my p-value should be 0.01. I hope you are able to understand what is the significant, how you will measure it, the significance value. The level of significance, that is 5%, 1%, 10%. That is nothing but 90%, 95%, 99%. Depends on your academic discipline, depends on your requirement. You can decide whether you want to go ahead with conducting this kind of, what kind of level of significance that you want to choose it. That is also one of the most important part of testing of hypothesis. Second one, there is one more important data concept, confidence interval. 95% confidence interval. So here I'm saying that there is a difference between population mean and sample mean is 1.5. Okay, 1.5 inches. As a scholar, I'm saying that an average 95%, I'm confident that there are people, 95% and confident that there are people, lower bound is 1.01. This is the mean score. Mean score means average. Mean score is nothing but average. Out of 407, we got 1.5 average difference we have it between population and sample mean. But as a researcher, I'm confident in saying that there is a difference, confidence interval difference is that it is between 1.01 to 2.05. Means actual height as per the population is 66.5. But in Gujarat, we got 68. average height is 68. But there are people less than 68. How much? 1.01 inches less. And there are also plus. How much? I have to say that 2.05. I have to say that not 68 plus. It is like 1.5. It is a mean. Upper bound is 2.05. The level of precision should be always should be less. If there is more gap, the level of precision, precise score, if you're not getting it, people may not able to rely on your findings of it. Means the confidence interval should be always should be less. It gives very precise score for the people to rely on it, your findings of your study. Before going to next slide, I want to tell you that though on average there are 1.53 mean difference, but there are people with a lower level 1.01 means they'll go with the people less than 68, that is 1.01. There are people greater than 68, it will go up to 2.05. Okay. How to interpret this data? Suppose you want to estimate the average exam score of students in large class. You take the sample, calculate 95% confidence interval. Like for example, you got lower bound 75 and upper bound 85. Upper bound 85. This means 95% confident that the true average exam score for the entire class is between. Means the people belongs to Gujarat state. The people belongs to Gujarat state are falling between these particular numbers. Okay. That's how we can able to interpret your findings. Like less than is low height is 75, low marks is 75, higher marks is 85. Minimum value, maximum value here. You can able to see that. Okay. Finally, before going to question answers or before going to next session, we have done the framing hypothesis. We also discussed about few concepts as a part of testing of hypothesis. But when it comes to concluding your hypothesis or writing your report, one important point is that nowhere we are going to say that we are accepting our alternative hypothesis. We are going to say that either rejecting null hypothesis or fail to reject the null hypothesis. You can never definitely prove the null hypothesis. The absence of evidence to reject it does not mean that it is true. It only suggests that the data did not provide sufficient evidence to support the alternative hypothesis. In other words, failing to reject the null hypothesis means that the test did not find enough evidence to support a chance or effect, but it does not prove that no effect exists. On the contrary, rejecting the null hypothesis means that the evidence supports the alternative hypothesis. Okay, so this is about the first session as a part of first 1 hour. Before going to talk about SPSS, I would like to know if there are any questions. Shall I want me to go with the questions? Shall we continue the session? Let me see if there are any questions. Anybody would like to add any point? If you have any questions, please feel free to add it also. Are there any questions? Any one of you? So somebody asking about p-value. As a part of my hypothesis, we are going to say that there is no significant difference between a couple of variables that you're looking at. For example, I'm looking at the employee satisfaction. Employee satisfaction. Now, employee satisfaction depends on the various factors like pay, leadership style, work culture, infrastructure. So many factors are going to influence how, as an employee, you're going to be satisfied with that. So both internal factors, sectional factors are going to influence. I'm taking one independent variable like work culture. How work culture is going to influence the employee satisfaction. I'm saying that there is no difference between let me put it like there's no difference between level of employees like assistant professor, associate professor, and assistant professor. We have three types of professors, or I can say four types of professors. I'm saying that we have senior professor, professor, associate professor, and assistant professors. I'm saying that there is no difference between academic performance of employees on the basis of their academic level. Here I have two variables. Academic level is one variable. Academic performance is another variable. Academic level is independent variable. I have four categories: senior professor, professor, associate professor, assistant professor. Okay. And when it comes to my second category, dependent variable is academic performance. Like I'm looking at APA score, academic performance index. Okay. Now I just want to, my null hypothesis, there is no difference between employees on the basis of on the basis of academic level. Okay. Now my null hypothesis, I'm framing there is no difference. When it comes to the p-value, if my p-value is going to be less than 0.05, it shows that there is a significant difference between academic level of the employees and their academic performance. If my p-value is going to be less than 0.05, if I'm going to take 95%, right? If I'm taking 99%, I'm going to see whether 0.1. The p-value should be less than 0.01 if I take 99. But if I take 95, my value should be less than 0.05. Any questions before going? Somebody asking, please give interval. Uh, somebody asking, is it break? You want break? I don't think, do you have any break in this between? Sir, do you have any break in between? No, right? Okay. Any questions? Shall I go with the next session that is talking about SPSS software? If there is no question, good evening. I'm PG student. You are changing. I'm changing the slides just because I need to talk about particular concept, right? Okay. Finally, are there any questions? Shall I go ahead with next? If, okay, I'm going ahead next. How many of you installed SPSS software? Please raise your hands. May I know how many of you are able to install SPSS software? Okay, there are hardly one or two. Okay. Let me start from my side. I'm sharing my screen again. I'm opening SPSS software.
Dear sir, very good evening. Sorry for the disturbance, sir. Since participants are doing the hands-on session, they are asking for a 2 minutes break. Can we give a 2 minutes break, sir?
Please, sir, please, definitely. I'm fine with that.
Yes.
Sure, sir.
Okay, dear participants, as per request in the group, we are giving you 2 minutes break. We will start the session by 7:15. I will repeat. We will start the session by 7:15. Thank you. Yes, sir, you can start, sir, now.
Yes, sir. I request all the participants. I hope I'm audible to all of you. And I believe
Yes, you're audible, sir.
yes, thank you, sir. Thank you. I believe the scholars, those are practicing along with me. Please ensure that you start sending your reactions or saying yes, no. Okay. And second thing, as already mentioned in the text message, I have already copied a couple of sample files in the Google Drive. Have shared three folders. One is SPSS folder. Second one is NVIVO. Third one is mixed method. I have already shared a couple of sample files. I request you all.
Yes, sir,
Please,
that we have shared in the group, sir.
yes, sir, yes, sir, yes, sir. So in that particular sample file, if you open your sample file, you can able to see SPSS folder. I have given you a couple of sample files for today. So every day before coming to session, at least by 5:30, 5:45, please check this particular folder. I'll be uploading new files day-wise. Okay. So today we are having three files: demo 1, demo 2, and educational statistics. By the time I introduce the SPSS interface, please start downloading this particular data on your desktop, especially those who are practicing along with me. Okay. Yeah. Now I have opened the SPSS, and if you look at this particular SPSS interface, just like any other application that we use in our daily life, like for example, those installed today, you might have installed version 30. There is a new version, 30, 31 is a new version. But I'm right now currently using 27th version, this is the old version. But the only difference is that in my case, I have data view, variable view. In your case, we have one more view, that is overview, overall view. Okay. That may not help right now, that is not useful much. But data view and variable view, these are the two important windows which we are going to use it. If you compare with the Excel sheet, if you look at the Excel sheet, we'll have sheet 1, sheet 2, sheet 3. And you can keep expanding number of sheets as per a requirement. But when it comes to the Excel sheet, we are going to have only two windows, data view, variable view. Okay. On the top of this particular window, we have ribbon bar like file, where you can talk about opening the file, creating the new file, saving file, exporting the file. There are so many options which we are going to use in coming coming slides or coming with the help of the various statistical tests. Edit. Right now, many of the options are not activated because we haven't entered the data. We don't have any data. It is empty spaces. Okay. That's why many of the ribbon bars, menu bars are not activated here. Okay. View. We can able to view the status bar, toolbars. You can also unselect it. Data. Whenever you are going to work on your data, sometimes it is also required for us to clean the data. It is also required for us to make certain changes. What all changes I'll discuss time. Okay. So this particular data window, data ribbon bar is going to help us to uh, make certain changes like cleaning the data and all. Okay. Split the file, split the data and all. Okay. Coming to the data transformation. Basically, we are going to use certain data transformation techniques like computing the variables. Like for example, when I was collecting data, I collected data like what is your age? I collected data from 100 people. I didn't give any classification like 18 to 25, 26 to 35 and all. But my supervisor suggested that I need to convert my quantitative data into qualitative data. So I can convert my quantitative data into qualitative data by using certain data transformation techniques. So we are going to use that as well. I'm going to explain. Coming to the analyze. Analyze is nothing but what are the statistical tests that you want to conduct it. Name it single frequency, cross tabulations, pie charts, diagrams, name it any chart, name it any statistical test like correlation test, regression test. If you are, for example, if you are dealing with a scale, like for example, if you hang a reliability test, if you want to do it multi-response test, name it any kind of statistical test, one can able to do it except structural equation modeling. If you want to do structural equation modeling, you required CBSIM or SmartPLS. CBSIM is required for different purpose. SmartPLS software is required for different purpose. So SPSS is going to help you most of the statistical test. Okay. So these are all statistical tests we have it. Okay. Next one, we have graphs like charts, diagrams, you can create it. Rest of the options, as a researcher, as academician, you may not able to use it unless until if you are thoroughly working with most of the other options, right? So these are some of the important menu bar that we see, that we use as a part of our day-to-day work. Now, coming to the data view, variable view, what it is. Data view is nothing but I have collected data from 100 people. These are all responses are going to be there, 100 responses. Here, data view is nothing but the responses that I have received. Okay. Whereas variable view is nothing but the type of questions that I have prepared as a part of my research tool, like questionnaire ID, gender, age, what are all the questions that you have included as a part of your research tool that is going to be part of your variable view. So variables are going to be in one page. Entire data that you collected, that is going to be in one window. Okay, data view, variable view. Okay. Now, let me save this particular file. How to save this particular file? Just go to File, click Save All Data. Save content. I'm repeating again. Let me type first here A. I typed some letter A. Go to File. I'm repeating again. I just typed A and I want to save this particular file. Go to File. There is option called Save As. Just click on Save As. Now it's asking where you want to save this particular file. So you can choose the destination, whether you want to save it on desktop, whether you want to save it on D drive, E drive, wherever you want to save this particular file, you can save it. Like for example, I'm saving with the name of demo. Now the point that you want you to recognize or observe is that when you are saving this particular file, you are going to get the extension star.sav. Like for example, if you are saving Excel file, you'll get XLS, right? Or if you are doing in the form of CSV format, CSV file, or .doc, Word document, PPT or PPTX, these are the file extension. So star.sav is the extension file of this SPSS file. Just click on Save. I've saved this particular file. You can see that name of the file is demo.save. Okay. Now, I just want to enter the data manually. How to enter the data? Let's say, for example, I'm giving like serial number one. I type serial number one. I'm just clicking on tab button. I want to go to the next column. It is saying that variable name contains an illegal first character. It means it is not taking serial numbers. Let me repeat it once again. I'm typing like 99. I have typed it. I want to go to the next column. So it won't take starting with serial numbers. It won't take, first point, don't take starting with serial numbers. Second one, I want to type it like questionnaire number or questionnaire ID. Name it anything. So what I did, I gave the space. Q, I have given the space and I mentioned ID. So I'm going to the next column. It is saying that again there is an illegal character. Means The variable, we have to type it only as a one word. You cannot write like gender of the respondent, gender, age of the respondent. We have to type only one word. Let's say, for example, I'm going to type here like questionnaire ID. What I did? Questionnaire, I did a small slash and ID. Now it is taking it. Let's say, for example, another term, gender. I'm giving the space gender of respondents. Respondents gender. Let's take for example, respondents gender. Have given two words. I've written more than one word. Now if I'm going to second column, it is not taking it. So what I can do here, I can type in short form. Gender, people can understand what it is. But in case, imagine that I have collected data from the parents as well as children's, or I have collected data from teachers and students. Now here I'm going to type gender of student teachers. Teachers gender, whatever maybe, you can just teachers gender, right? So here now it is going to take what I want to say, that as a part of variable view, we have to type only one word. But sometimes it is going to confuse, right? Just writing short word or one word may not be help you. So SPS has given one more option here, that is nothing but the label. Here I'm going to type teachers gender or respondents gender. Whatever I can type label, respondents gender. Respondents gender. The best part is that one of the important point is that however you are going to type in the label, this particular label is going to be reflected in your output of the data. Like for example, if I'm preparing any table, cross tabulations, or if you are preparing any chart, name it any chart, pie chart, bar chart, anything, how the title should be reflected. If you want, that way you can able to type it here. Again, if you type short form, if you don't type properly here, we have to rework again. When you copy your tables, charts, you have to rework. You have to make a lot of editing work. You have to do it. In order to save your time, just give the proper title, how this particular title should be reflected in your output. Okay. Here, respondent gender. Now, coming to the questionnaire number ID. Next column is type of variabilities. Type of variabilities. For example, we are talking about numerical values. As a scholar, as a researcher, mostly we are going to use numerical values. But if you have data something related to employees, date of joining, or employees promotion, for example, as a part of HR, you might be dealing with your HR people in your office. They might be calculating when you joined, how many days leave, which day you are on leave, or if you're talking about increments, or if you're dealing with currency. So it depends on the variable that you have it, you can choose it. By default, it is always show numeric because 99.9%, except few cases, we don't change this variable type. It is going to be numeric type. Second one, width. By default, 8 width, the size of the that value, the size of this particular column, it is 8 width. Decimals. Decimals I'll show you right now. Like for example here. For example, when I say gender is going to be 1, right? We are going to give code like 1 for male, 2 for female, or 0 for male, 1 for female. So decimals, you should know when to use the decimals. For example, if I'm talking about height, if I'm having continuous data, there is a requirement of using decimals. But if it is something like ratio data, if something like nominal data, ordinal data, the decimals are not required. Okay. So decimals by default, it will show 2, but you can able to make changes. Otherwise also people can understand there is no use of decimals here. Now questionnaire ID, we are going to have collect the data from 100 people. So we not give any values. Missing values. There is always possible that one or the other respondents might not be answering one or two questions, like with reference to age, with reference to annual income, with reference to property, right? So in that case, if a respondent is not answering it, how to consider them? So you can say that I just want to consider missing values as 999, something like that. If there are, whenever you are finding any missing values, you should consider as 999. Whenever there is missing value, okay. Now column width is 8. This is not helpful. It shows how you are aligning the like right, left, center. It's not making any sense. If you want to make beautification of this particular window, only for that particular purpose, okay. Otherwise, it won't make any sense for the data. Okay. Now coming to the levels of measurement, as already discussed, having knowledge about levels of measurement is going to help us, like nominal data, ordinal data, interval data, ratio data. But in this particular spaces, it is showing only 3 levels: nominal data, ordinal data, scale data. Means both quantitative, interval data and ratio data, it is considered as under quantitative data. In SPSS, in Jamovi, or name it any statistical software, you will be able to see nominal data as a separate measure, ordinal data as a separate measure. But when it comes to quantitative data, either it can be interval data or it can be ratio data. It comes under scale data. Okay, it comes under scale. Okay, so having knowledge about the levels of measurement is going to help you. Right now, I'm not touching this particular part here. Okay. Now coming to the gender, it is a numeric. We are going to have numerics. Have typed respondent gender. Coming to the values. If you look at your research tool, we used to code the data. Like I'll give the value for 1 for male. I'm repeating again. The values are nothing but how we code our data. How we code our data. As a part of our questionnaire, we have gender, age, a lot of data variables we have behind. So we are going to give the code. Like you can click on this 3 dots. The scholars, those who are new to the SPSS. If I keep my cursor here, if I click here, I'll get the new window. Whenever I'm keeping my cursor on this particular 3 dots, if I'm clicking here, I'm getting the new window. I'm going to assign values. For example, value 1 for male. Please let me know if I'm going very fast. If there are students, if there are PhD scholars, those are if you are new to the SPSS, I'm not here to complete the syllabus. Okay, please.
Sir, very good evening, sir. Again, sorry for disturbance. The screen is not visible, sir. Only your face is visible.
My screen is not visible.
Yeah.
It is from the beginning, just now.
Just now, sir. Yes, it is visible now. Yes, sir. It is okay now. Fine.
You are able to see SPSS?
Yes, sir. Yes, sir. Yes, sir. Yes, it visible.
But was it their problem from last 10-15 minutes?
Yes, sir. From space is not visible, sir. When
Oh,
it was it is visible.
okay.
Okay.
Uh,
Okay. Okay.
okay. Thank you, sir. Thank you. That is the reason I asked, especially the scholars, those are practicing along with me. Tell
Yes,
me
yes,
that.
yes.
Yeah, please. Yeah. Okay.
Yeah.
Now I'm repeating this step here. Under this particular values, if I keep my cursor here, I'll get this particular new window. If I keep my cursor on this particular 3 dots, I'll get new window. Here I'm going to assign the values. 1 for male, 1 for, after giving the name of the label, just click on add. Just click on the add. I have one more category of the respondent, female. So I'm typing here female. I have one more category. transgender. Transgender. Just imagine that I did some mistake, like I did small mistake, spelling mistake. I already added, but there is a mistake in my label. I need to correct it. I need to, after entering all the three labels, male, female, transgender, either I want to correct it or I want to delete it. One of the, if you want to simply delete it, just I select that particular label, click on remove it. I'm repeating again. After entering all the three labels, there is mistake in the transgender. Okay. If I want to remove this particular label, after selecting this particular label, just click on remove it. But if you want to make corrections, again go to the label here. After selecting it, we have to select it, then only it will be highlighted here. Now I corrected it. Now change. Now you can see that transgender is corrected. Now click on OK. I'll repeat this step in coming 3 to 4 variables. Okay. So in case if you are not able to follow it, please follow me again. So it shows the values: 1 for male, 2 for female, 3 for transgender. Okay. So missing values will come to know once we enter the data. Okay. Or once we import the data. Right now, we are not going to do anything here. And level of measurement, it is a nominal data, right? So we are selecting it. Next one, age. I have typed the age. Numeric, it is going to be age, like our age is going to be numbers. By default, 8. Here I'm going to type respondent's age or age of the respondents. How your title should be reflected in your output, that is very important. Age of the respondent. When it comes to values here, I don't need to enter any values because I'm asking what is your age. I'm not giving any answers like less than 18 or 25 to 35, 35, 36 to 45 and all. I'm not giving any classifications. So in that case, we're not going to give any values here. But imagine that maybe because of my supervisor or maybe because of data requirement, I want to give the values here. I want to give the specific classifications here. So in order to give the classifications, again, just click on 3 dots. I got the new window. 1, it should consider between 15 to 25. I can say that 16 to 25. Okay. 2, 26 to 35. If you want to add classifications, this is how we are going to work on it. Okay. Just 1, 2. Next one. Let me take another variable, height. Height of the respondents. It is a numeric. Here, I am not typing here, height of the respondent. Now, when it comes here, height of the respondents, decimals are going to be required here. Whether you want to go for 3 decimals, 3 decimals, 2 decimals, choice is yours. By default, it is giving 2 decimals. But for age, we don't require decimals. For gender, we don't require. For ID code is not required. Why for height decimals are required? I'm going to tell my height is 6.5 feet. Sorry, 5.6 feet or 5.9 feet. Or I can tell that 66.5 inches. If it is continuous data, there is a possibility that you may get some decimals as a part of your it. So again, here we're not going to enter the data. It depends on the responses that you're getting on it. Next one, I'm trying to measure the attitudes or perceptions of the teachers. So here I have Likert scale. I'm talking about attitudes of teachers towards usage of AI, usage of artificial intelligence in their teaching pedagogy. Okay, or as a part of their day-to-day life. Okay, attitudes of teachers towards or adoption of AI in their teaching. Okay, so here Here I'm going to have Likert scale statement. Again, same, just procedure, just click on the values. 1, just in order to save the time, I'm not typing completely. You can type it like strongly disagree. Label 2, disagree. 3, undecided or neutral. 4, agree. 5, strongly agree. Now, just imagine that I don't have one questions, one item, two items. I have more than 20 items, 30 items. Okay. But if the anchors are going to be the same, anchors means like the responses, like strongly disagree, strongly. If I'm not changing the context, like here I'm talking about strongly disagree to strongly agree. So there are so many anchors. It depends on the context, like satisfied, not satisfied, often, rarely, and all, right? These are all called anchors. What kind of anchors that you are giving for your respondent to tick mark as a part of your Likert scale. Imagine that I have around 5 to 10 questions, same answers, same anchors. So what I will do, I keep my cursor here, I select it, Control C, I'll go to next window, next cell, Control C, not happening yet, copy. Control C, Control V. Is not happening, some technical issue. So what happens is you can able to copy all the anchors number of times that you want to do it. Somebody can do it. Is there anyone doing? Please let me know. Are you able to copy and paste? Copy, paste. No, it's not happening. Okay, let's leave it. Now, Likert scale also you can able to do giving anchors like this. Now, one of the most important and last type of variable that I want to discuss. Imagine that you have question where you are asking multiple responses. Like for example, I'm asking what are the hobbies of teachers? Watching TV, playing cricket, spending time with the family, reading books, whatever may be that. Okay, we have different type of hobbies we have it. Now, as a researcher in your research tool, you always give choice for your respondent. Tick more than one question, tick more than one answer. I'm repeating again. This is the most complicated. It is very difficult to do it in Excel sheet, but it is the most easiest way to do it in an SPSS. Whenever you have multiple responses, I'm asking what are the hobbies we have it. So as a person, I'll tick mark more than one answer, right? So in that case, how we are going to analyze it? Before talking about analysis, how you enter the data. Here I have hobbies, reading, watching movies, traveling, okay, shopping. So here there is always chance, there is always scope that respondents are going to tick mark more than one. Tick mark more than one. When it comes to entering in SPSS, we are going to take every response as a single question. How I'm going to enter here? Let me show you here. I'm going to enter here reading hobbies. Reading hobbies. And when it comes to the label, when it comes to the values, here I'm going to type 1 for yes. And I'm going to type 2 for no. Like this, you are going to enter all 4 answers. you are going to type all 4 answers here, you are going to type it. But if you're not giving choice more than 1 tick mark, then there is no problem. If you are giving choice, multiple choice, like more than 1 tick mark, if I'm going to tick mark reading plus shopping, in that case, we have to follow, like reading hobbies is one, it should be considered as one question. Next one is shopping. Hobby is one, second, it is as a second. Again, I'm going to type 1 for yes, 2 for no. But if I'm not giving more than 1 tick mark, I'll type like this: 1 for male, 2 for female, just that's all. Like I'll give hobbies. Here I'll type 1 for traveling, 2 for shopping, 3 for watching TV, like that. Okay. So these are some of the important things one should know while typing the data manually in SPSS. So we have typed 3 or 4 different types of data. These are the basic types of variables. One should know how to enter the data manually if you're doing it manually. Okay. Now here I can save this particular data. I can simply save as it. I can also export this particular data. I can export this particular data. Let's take, for example, you are a PhD scholar, you have access to SPSS, but your supervisor is not having SPSS. It must be other way. I'm just saying that, okay? Or maybe you want to consult someone. That person is not having SPSS. You want to consult some subject expert. That particular person is not having SPSS. So you want to convert your SPSS data into Excel data. So one can able to convert your SPSS data into Excel data, CSV data. There are a couple of other statistical software. Even I'm not aware of many of the statistics. Like SAS is one, Stata is another one. Other I'm not at all familiar. Okay, so I can convert my SPSS data into Excel data. Similarly, if I'm using SPSS, if somebody send me Excel, I can import that particular data. Let me show you right now how to export it. I'm just clicking on export. I'm typing it as demo. Let me put it to. Save it. Let me open my window. Look at here. I got this variables. These are the variables I have entered it. We haven't collected data so far. Now, I just want to import the data because as many of us are collecting data by using Google Forms or online surveys. So I want to import the data. So in order to import the data, either you can close it, either you can close this particular window, or simply go to file. Simply go to the file. If I'm going to import the data from Excel CSV format, I have to go to import data. But if I'm going to open only SPSS file, I can go to the open only. Right now, I just want to import the file that I have collected by using online survey, Google form. So for that, I'm going to import data. Click on Excel. Go to the particular destination wherever I have given. Go to the particular destination. I have given you some files. I'm going randomly with some file, but I have already shared a couple of files with you. Okay. So I'm just going to open one file, that is Excel file. The first one window you'll get it. You don't need to make any changes. It is showing that you are trying to import some data. What are the characteristics of the data? It is showing that one. Okay. Just simply click on OK. Simply just click on OK. So I'm able to import this particular data. This is not the correct file. Let me import another file. Go to import option, Excel. There are no Excels. CSV file is there? I have CSV file. I think even I have given you all CSV file. One file name is demo1. Second file name is education statistics. The same file I have given to you all. Okay. I have selected this particular file. Name of the file is education statistic practice data. Just click on OK. Next. 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 Finish. Till you get the finish option, just click on next, 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 next. Once you select the file that you want to import it, just click on next, next, next. No need to make any changes. The moment you click the finish option highlighted, just click on the finish button. See that I have imported the data, around 125 responses. Okay. This is just like how we are collecting data from the Google Form online forms. Tomorrow, what I'm going to do is, once we collect the data from the Google Form, we cannot go for directly using it. We have to clean your data. We have to make certain data transformations like computing, recoding. That all I'll discuss in tomorrow's session. So today, what we have discussed as a part of the second session, we have opened the SPSS. We have discussed about the interface of SPSS. What are the ribbon bars we have it? How to enter the data manually. Especially, I have discussed about 3 to 5 different types of variables, which generally are, I can say that, which are maximum. These are the different types of variables. We should know how to enter these particular variables, how to code the variables, how to select the decimals, how to select the variable name, like with one word. Okay. And we also discussed about measures like nominal data, ordinal data, scale data, and all. Okay. So this is all about basic introduction about what is SPSS. And lastly, we also discussed about how to save the file, how to export the file from one format to another format. Similarly, how one can import the file like CSV file into SPSS. This is what for today. And still we have around 10 minutes time, 5 to 10 minutes. If you have any questions, please let me know so that I can take a couple of questions. Dear scholars, if there are any questions, please let me know. I can see some questions in the chat box. Screen is not visible. Please share the screen. I would have felt very happy. The people, those who mentioned screen is not visible. You have mentioned, we have switched to your mic and you have told me. So many comments were there. Please, next, please. Today's session is very worst. I'm leaving it. Okay, who is this? Any questions? Please let me know so that I can able to answer your questions. Thank you for the informative session. Thank you. Okay, sir. From my side, I have done it.
Okay, sir. Okay, sir. So, dear participants, thank you so much for your successful participation and cooperation. And we have given you a number of notifications. Don't unmute yourself before the technical session, since you keep on disturbing the others. That is why we are forced to lock the meeting. That's why we are unable to see when Shah was sharing the screen. Hope tomorrow those things will be rectified accordingly. Even though the technical team is doing their work sincerely, but we need the cooperation of the participants too, which enables smooth flow. Otherwise, no, because of one person's knowingly or unknowingly doing the reason, other people also will be going to, by default, they are also going to be the victim. So tomorrow, let me again open the meeting for all. Hope you won't disturb others. If it is so, definitely the technical team uh, may lead to the force to lock the meet again. Thank you so much, everyone. Thank you so much, sir.
Thanks,
And
sir.
still, sir will be taking class for remaining all the 5 days, requesting you to do the homework which was given by the sir, as well as kindly check all the drive. He has given the drive link and the link I have shared in the group also. So kindly check it and update everything in the drive itself. I hope to see you tomorrow at right time. Thank you so much.
Thank
Good
you.
night.
Thank you,
And
Sujata.